This is part 2 of the Unit 9 notes. In this video, we will be covering one-step stoichiometry conversions. One-step stoichiometry conversions occur when your substance is constant, or when you go from moles of substance A to moles of substance B. So if you were to look at stoichiometry islands, there's two possibilities. In the diagram on the left, you can see we're going from mass to moles, volume to moles, or particles to moles for the same substance, so we're always at substance A. You could also possibly be going from moles of substance A to moles of substance B. Any other combinations could potentially be a 2 or a 3-step conversion, which we will cover in future videos. For the rest of these slides, we are going to be going through checkpoint questions, which you should be writing out within your notes. You are also going to need a scientific calculator in order to work through these. For our first checkpoint, we are given 6 moles of hydrogen which are reacting, and we are trying to determine the number of moles of ammonia which are going to be produced. So I'm identifying this as my starting point, and this is my ending point. And since I am going from moles to moles, I know this is going to be a one-step conversion. You should write out what you're starting with. So we have 6 moles of hydrogen, which is H2. Going to set up a conversion factor, and we only need 1. Whatever unit I had before is going to go down to the bottom, and whatever unit I'm looking for is going to go on top. So that's moles of ammonia. Remember, when we are going between moles and moles, we are getting our numbers from the balanced equation. So in this instance, we're looking at the 3 for the hydrogen and the 2 for the ammonia. So I have 2 over 3. So we're going to take 6 times 2, and then we're going to divide by 3. So that is going to be 4. So 4 moles of NH3. As we go through each of these calculations, you should be taking into account significant figures. On this one, it's simple enough. We start off with one significant figure, so we are ending with one significant figure. The significant figures of the numbers within the conversion factor are not going to factor into your final answer. In our next checkpoint question, we are going from moles to grams, and it is the same substance the whole time, so this is going to be another one-step conversion. In our problem, it looks like we are starting off with 5 moles of silver, and we're trying to find the grams of that silver. So we're going to write out 5 moles of Ag, and for our conversion factor, moles of silver is going to be on the bottom, and grams of silver is going to go on the top. 1 mole is equal to the molar mass, which is the mass that you would find on the periodic table for an element or a compound if you add everything together. Here we have a singular element. This is going to be 107.87. I should also point out that when you're trying to find the molar mass of a substance, you should use the periodic table that I gave you in class. That way your answers are going to match up more closely if you're looking at, say, any of our Kia assignments. Otherwise, your answer might be off by a little bit, and then Kia would mark it incorrect. All right, from here I am going to multiply across. I end up with 539.35 grams of silver. Now, this is actually not our final answer. I mentioned before that we need to use significant figures based on whatever our original starting number was here. And this 5 only has one significant figure, which means I need to round this number right here to one significant figure as well. That means I can keep the 5, but I can't keep any of these other numbers after it. I do need to keep this 5 within the hundreds place, so I can use 2 zeros as placeholders, as long as I do not add a decimal. So our final answer here is going to be 500 grams of silver. All right, for our next checkpoint question here, we are starting off with 48.2 liters of oxygen, and we are trying to find moles of oxygen. So since we have the same substance, this is another one-step conversion. I'm going to write out my 48.2 liters of oxygen, which is O2. I'm going to cancel out liters to moles. 1 mole is equal to 22.4 liters. So this you could get from stoichiometry island. From here we are going to divide. I end up with 2.15 moles of O2, and that is rounded for the 3 significant figures that I have here. For our next conversion, we are starting with 3.8 times 10 to the 23rd molecules of the carbon monoxide, and we're trying to find the moles of the carbon monoxide. So I'm always writing down whatever we're starting with, so 3.8 times 10 to the 23rd molecules of CO molecules of CO is going to go on the bottom so that it cancels, and then my moles of CO are going to go on top. 1 mole is going to be equal to Avogadro's number, 6.022 times 10 to the 23rd molecules. All right, from here when we divide, we're going to be rounding for the two significant figures that we have right here. So that's going to come out to 0.63 moles of carbon monoxide. All right, so each of those checkpoint questions should give you a variety of the different possibilities you can have for a one-step conversion. In our next video, part 3, we will cover how to solve two-step conversions.